Welcome to this live section. Good evening, good afternoon, wherever you find yourself across the globe. We still continue on the use of undetermined coefficients for solving second order differential equation. Okay, if this is your first time, don't forget to subscribe, like, and share the links of this video across your different platform. We've already established that when you have this equation and your f of x is not equal to 0, we call it what? Non-homogeneous. So the first thing we do, step 1, is to get the homogeneous equation. This part equal to what? Equal to 0. Get the homogeneous equation, because this involves, we are going to get the in this case that we need for us to get the solutions of the homogeneous equation, and that we need for us to get a particular solution for the what? For the non-homogeneous parts. Okay, so the solution will be equal to what? The general solution will be this. Okay, the solutions of the homogeneous parts plus the solutions of the particular solution of the particular solution. So this is what we want to get. Okay, so this is the what? This would lead to this. So this is the homogeneous parts. This is the homogeneous part. Then get the auxiliary equation. Get the auxiliary equation. And we're going to use this standard auxiliary equation. Okay, and correspond this one to our question, where the A is the attachment to your second differential, and in this case is 1, where your B is what? Is 3, where your C is a coefficient of your Y, and that will be equal to what? R squared plus 3R plus what? Plus 2 equal to 0. And then you now factorize this one. You factorize this one. This is your auxiliary equation. This is your auxiliary equation. Get this R squared, 1 here, and then plus 2, and then plus 1. Okay, so this is equal to 0, or this one also is also equal to 0. So R is equal to minus 2 or minus 1. Okay, so in that case now we can get one of the roots. One of the solution, this will be equal to what? E to the power minus 2x. Okay, because our function is a function of x. Okay, so we have this. Y2 is equal to what? E to the power minus x. So the general solution for the homogeneous parts, the general solution, okay, or the complementary solution is equal to C1 y1 plus C2 y2. Substitute your y1 and your y2, and that will be equal to what? That will be equal to my C1, we don't know, but my y1 is e to the power minus 2x plus C2. My y2 is what? E to the power what? Minus x. So that's the homogeneous solution of the differential equation. If this is your first time, please subscribe to the channel. Subscribe to the channel. If this is your first time, subscribe to the channel. Begin to share the links across your different platform. Share the links across your different platform. So then the next thing to do now is to get the particular solution, f of x. Get your particular solution. If you look at your f of x, you want to get the particular solution, which we don't know. So we're going to consider the right hand side, which is the f of x. F of x is of this form. This is what we have. Okay, and according to the rules of undetermined coefficients, I said that if your function is this form, okay, your yp will be equal to, look at this one. is having power 1. Okay, is having power 1. And that will be linear equation. And that will be of this form: ax plus what? Plus b times what? Times this one. E to power what? E to power 3x. Okay, this is a linear x to power 1. So then the next thing to do now, you need to confirm what you have here. The exponent of the e is 3 here. Do we have any 1 here? Do we have in this homogeneous equation, do we have any, is our r equal to 3? Check the root of the auxiliary equation. Do we have anywhere where the r is 3? No. No. We only have -2, -1. Okay. So that means this is what? This is okay. But in case where your r is 3, okay, and it's the same with what you have here, you're going to multiply this equation by what? By x. Okay. But in this case, we don't have such case. None of the roots of the auxiliary equation is equal to 3. None of them. Okay. Get your first differential. Get your first differential. Get the first differential. That will be equal to what? This will be product rule. Okay. I'm going to differentiate this one first and keep this one constant. If you differentiate exponential function e to power 3x, it's going to give you the same exponential function times derivative of the power. So I'm having 3 here times the one I'm keeping constant. Okay. Plus, now keep the e function constant and differentiate this one. Okay. And that will be a, if we differentiate this one, okay, ax, that will give you a. This is a constant, b is a constant. You have a times what? E to power 3x. Okay, that's your first differential. Get the second differential. Get the second differential. Differentiate again. Okay, differentiate your e function. So that will be 3. That will be 3 times the e function. So this one times 3, that's 9. Keep this one constant. Okay, e to power 3x plus. Can you keep the e as a constant? Keep it constant with the 3. Keep them constant and differentiate this one. Okay, that will be 3 a e to power 3x. Okay, plus what? Plus, now differentiate this one, which will be what? 3 a e to power 3x. Keep the a constant. A is a constant. Differentiate your e function. So this is what we have in this case, which is equal to 9 times ax plus b times this one and this one will give us what? 6a e to power 3x. If you begin to substitute your second differential here, the first differential, the initial solution, substitute everything in place. Okay, so let's do that. Equation 1 or equation star, substitute into equation star. So second differential is 9 times ax plus b e to power 3x plus 6a plus 3 times the first differential. My first differential is this one. Is the first differential was equal to x e to power 3x. So that's what we have there. So that's what we have. So we're going to open the brackets. We're going to open the brackets. Open this one. Okay. That's what we're going to do. And then we factorize. Open the brackets. Open the brackets. Open the brackets. So that will be this one times this one. That's a 9a x e to power 3x. This one times this one, that's a plus 9b e to power 3x. plus 6a into power 3x. 3 times 3, that's 9. That's 9 times ax, that's a plus 9a x into power 3x. Okay. Again, 3 times 3, that's 9 times b, that's a plus 9b into power 3x. And then find on that place 3 times this one, that's a plus 3a into power 3x. Okay. Plus this one times this one, that's a 2a x times this one e to power 3x. And then plus 2b, this times this, then times this, e to power 3x equal to what? X e to power 3x. So we can group all this one, all these e times e to power 3x. We can group them together. One is here, one is here, one is here. Okay, making 9 plus 9. That's 9a plus 9a. Okay, where again plus 2a, close the brackets, and that will be what? E to power 3x. So that's giving us 20. That's 20. That's 20. Then the next one, the one with e to power 3x, you can do that one also and group them together. 1, 9b. Okay, another e to power 3x plus 6a. Okay, another one again plus this one here plus 9b. Okay, plus 3a. Okay, plus 2b plus 2b. I think that's all. Plus 2b. Okay, plus 3a. Let's check the one of x e to power 3x. One is here. One is here. Okay. One is here. That's 2a. So there are three of them. 1, 1, 2, 3. Okay. So making 20, 20a, 20a x into power 3x. Don't forget to put your this one times plus 9b plus 9b plus 2b. That's 20b plus this, that's 20. And then this 2, that's a plus 9a times e to power 3x. Please like, share, and subscribe. Subscribe to the channel so that you can keep track of the update of this channel. You can keep track of the updates of this channel. Like, share, and subscribe. As you're coming in, just begin to say I. Okay? Just begin to say I. For my returning viewers, I want to say thanks for always coming on board. Thanks, kudos to you for always coming on board. Okay? Begin to share the links of this video across your different platform. Call your classmates to join us also. Equate coefficients. Equate coefficient. Equate coefficients. That's the next thing to do now. Let's begin with this function. Equate this, where you have it. Equate the coefficient of this. On the left side, we have it here. The coefficient is what? 20a. That's 20a. On the right side, the coefficient is what? Is 1 in this place. So that's 1. 20a equal to what? Equal to 1. Okay? So a is what? A is 1 over 20. A is 1 over 20. Then the other one is the e to power 3x. Equate the coefficient of that one also. Equate the coefficient of e to power 3x. Okay. On this side, we have 20b plus 9a equal to what? We don't have it on the right side. 0 on the right side. Okay, 0 on the right side, which you can make as what? On the right side plus 0 e to power 3x. Okay, so that's 0 on the right side. As you are coming in, just begin to say R. As you are coming in, just begin to say R. So we have 20b plus 9a equal to 0. My a is what? 1 over 20. 20 times 1 over, that's 9 times 1 over 20 equal to 0. Okay, this 20b. 20b. So make the 20b the subject. So we have minus 9 over 20, and b will be equal to what? Minus 9 over 20 divided by what? Divided by 20, which is times 1 over 20. Okay, and that will give us minus 9 over 400. Is to now write the particular solution is equal to don't forget, this is a particular solution. Okay, plug in the constant value. A is what? A is 1 over 20. Where is my A? Yeah, A is 1 over 20 times the variable. My B is what? Minus 9 over 400, close the brackets, e to 3x. Okay, so the solution, the general solution, will be equal to the homogeneous parts. The homogeneous parts, put it there, put the value there, plus the what? The particular solution, which is this. So put the 2 there, and then we have the final conclusion, and that is the end of the work. That's the end of the work. Another questions? Give the video a thumbs up. Yeah, if you look at this question, I try to solve this. Okay, this is second differential minus y equal to what? Equal to 3x. Okay, this is solution. This follows the standard form of this case. Follow this equal to what? F of x, where the f of x is this. The homogeneous part is this. That's the homogeneous part. Step 2, the auxiliary equation. Get the auxiliary equation. Get the auxiliary equation, which has a standard form. It has a standard form. Okay, this auxiliary equation with a constant coefficient. Now correspond this with the given differential equation. Okay, the attachment to your second differential here is 1. So a is what? A is 1. Correspond this one together. So you have r squared. Okay, why am I writing? This is minus. Why am I writing plus? Okay, then the attachment to your y is 1. So b is what? B is minus 1. Okay. Okay. Let me quickly make adjustments. Yeah, I said a is 1. Okay, but you have to note, wherever you see your r square is for second differential. R square is for second differential. R is for first differential. So we don't have R in this place. Okay, we don't have R in this place. Okay, so the second differential is for r squared. The attachment to your second differential is 1. So that means a is 1. Here, there's no first differential here. So that means B is what? B is 0. We don't have this one in this case. There's no first differential in the in this equation. Okay, and then the constant coefficients attachment to your y is 1. So that means C is what? C is minus 1. Attachment to your y here is minus 1. So C is what? C is minus 1. Okay, so then the auxiliary equation will now become r squared minus 1 equal to 0. R squared minus 1 equal to 0. And then this will be equal to r minus 1 times r plus 1 equal to 0. So r is equal to 1 or minus 1. So we can call this one r1 equal to 1, and then r2 equal to minus 1. So the first one, y1 is equal to what? E to power what? E to power x. Y2 is equal to what? E to power minus x. So the solution of the homogeneous parts is C1 times Y1 plus C2 times Y2. Okay, and that's equal to C1. My Y1 is what? E to power x plus C2 e to power minus x. That's my solution of the homogeneous parts. Okay, that's the solution of the homogeneous parts. Then the next thing to do now is to get the particular solution. Okay, which will be the right hand side. Okay, this is your f of x. Okay, and we have said in our note that if f of x is equal to I use e to power rx. Okay, I also put not here, r subscript 0 there. Okay, so in this f of x, our r in this question is 1. Okay, in this f of x, r is 1. Okay, so the yp will be equal to, will be of the same form, e times what? E to power x. E to power x. Then you now check the root of the auxiliary equation, the root of the homogeneous part, the solutions of the homogeneous parts. Okay, the auxiliary roots. Okay, the solution of the auxiliary equation, r1, r2, r1 and r2. Is there any one among them that is 1? One of the roots of the auxiliary equation is what? Is 1. So in that case now, you're going to multiply this place by what? By x. The function, your f of x is a function of x. So you're going to multiply your equation by what? By x, because one of the roots of the auxiliary equation is equal to the r in this place, which is 1. So that's that on that case. As you are coming in, just begin to say I. Share the links across your social media platform. Like, share, and subscribe. Second differential. Don't forget y. Second differential minus y equal to what? 3 e to power x. So my second differential is what? Is 2a. Second differential is 2a e to power x plus this one, okay, minus y. My y is the initial function equal to what? 3x. So this and these are cancelled out. Okay, I can now equate the coefficient of e to power x on the two sides of the equation. This is here. This is here. So that implies 2a is equal to what? 2a is equal to 3. A is 3 over 2. A is 3 over 2. In that case, I've gotten my a now. That implies that my particular solution, come back here, yp, put the a there. That's 3 over 2. times this one. That's my particular solution. Okay, the solution, the general solution, which is the homogeneous part plus yp. Okay, and that will give me c1 e to power x plus c2 e to power minus x plus the yp 3 over 2 e to power what? 3 over 2 x e to power x. And that finished that for the general solution, for the solution of the non-homogeneous differential equation. That finished that. That finished that. Let's see another questions. But before that, as you are coming in, just begin to say I. As you are coming in, just begin to say I. As you are coming in, just begin to say I. As you are coming in, just begin to say I. As you are coming in, just begin to say I. As you are coming in, just begin to say I. Share the links of this video across your different platforms.